We are going to review simplifying and evaluating expressions. First off, for these problems, I want to talk about what the directions would look like. What would the directions look like for these problems, and what would your answers look like? So first of all, what are all of these? They are expressions. Second, what are we going to do with these? What are our answers going to look like? Well, there's no equal sign, so we can't get an answer. We can't say A is 3 or X is 2. What we can do with these expressions is just to simplify them. Make them simpler looking. Use the distributive property, add like terms, and multiply. Okay? The first thing I want to do with these problems is to go through and look for the distributive property problems. Which ones use the distributive property? This one, and this one. The distributive property happens when you have a number outside the parentheses multiplied by an addition or a subtraction problem inside. Notice, this is not distributive property. There is no adding or subtracting inside the parentheses. This is just -4 times -3b, all multiplied together. This would become 12b. You don't have to distribute since there's no adding or subtracting. So up here, -8 times -2a. A negative times a negative is a positive, so that's 16a. -8 times +7b is -56b. That's our answer. That's as simple as this expression will get. Over here. Remember, again, the -4 right next to the parenthesis assumes there's a multiplication there. So we're going to multiply piece by piece. -4 times -3 is 12. And -4 times b is -4b. 12 minus 4b. I want to talk again about some other ways that could be written. You could switch your terms around. Being careful to keep the negative with the 4b and the 12 a positive. You could also write this as 12 plus -4b. Adding a negative and subtracting are the same thing. So any of the three of those is a correct answer. 3 times x squared minus x minus 5. Again, distributive property. Take the 3 and multiply it by everything. Those are all the distributive property problems. Let's look at anywhere we have to add like terms. And when I say add like terms, I mean subtract too, collect like terms. So here we have 3 terms, +3y, +3x, and -3y. The 3x, there's only one term that has x's in it. So we'll do that one first. Now, 3y and -3y, think money. You had $3, you lost $3, now you've got 0. So that's gone. You might be tempted to put 0y, but 0 right next to a y means 0 times y. And anything times 0 is 0. So that would just cancel out to be 0. So 3x plus 0, or just 3x is our answer. See, this one has adding or subtracting. Do we have any like terms? No. +3 and a -5x. This is the constant term. This is a variable term. They're not like terms. We cannot add them. So this one cannot be simplified. You can either write can't simplify or just circle that answer. Down here, we have 3 terms. -5x cubed, positive 2x cubed, negative 7x cubed. They all end in an x cubed. They all have the same ending, so they're all like terms. So we can add them all. Think money. Lose $5, win 2 back. So now you're 3 in the hole. 3 in the hole, and now you lose 7. So 3 in the hole and 7 in the hole makes you now 10 in the hole. Negative 10 x cubed. Notice when you're adding, the endings don't change. I don't make this into x to the 6th or x to the 9th or anything. It's like negative 5 of them, 2 of them, negative 7 of them, adds up to negative 10 of them. Just almost like a label coming along. Multiplication. When you multiply, you don't have to have like terms. I've got 3 and a 2x. They're not like terms, but it doesn't matter in multiplying. You just say, okay, the 3 and the 2 can be multiplied together to get 6, so this turns into 6x. Here, the negative 4, and the negative 3 get multiplied together to be positive 12. That's 12b. Let's read through this problem. Kate had a cumulative GPA her freshman year of 3.2 while taking 30 credits. She needs to keep her GPA above 3.0 to keep her scholarship, so she was good for last year. She is worried this semester because she has a couple of hard classes. If she is taking 16 credits this semester, but only gets a 2.5, will she keep her GPA high enough to keep her scholarship? In this formula, G1 is previous GPA, so that would be like the freshman GPA. C1 is previous credits, so that's the freshman credits. G2 is GPA during current semester, and C2 is the credits in the current semester. So first, what type of problem is this? What are we going to do with this expression? We are going to substitute this information from the problem into our equation, and then we will evaluate it. We will get out an answer. So we are going to evaluate this expression. Evaluate means when you have a formula, you put numbers into it and you get numbers out. We are going to get out what her GPA would be if this happened. So let's start to decide what numbers go where. The G1 is her previous GPA. So her GPA during her freshman year, that was 3.2. G1 will be 3.2. C1, her previous credits. How many credits did she take her freshman year? 30. That will be C1. G2 is her GPA during the current semester. So what we're using this to say is if she gets a 2.5, and credits, she's taking 16 credits this semester. So when we plug these numbers into this formula, we should get her overall GPA. We want to see if it's higher than 3. Will she keep her scholarship? So sub in G1, 3.2, times C1. Remember, when two variables are right next to each other, multiplication is implied. C1 is 30. G2 is 2.5 times C2 is 16 over C1 plus C2. C1 is 30. C2 is 16. Now we'll simplify this to see what her GPA would be under these circumstances. So, order of operation. Remember, a fraction bar is like a parenthesis. So I'm going to pretend that all the stuff on the top is a parenthesis and all the stuff on the bottom is a parenthesis. I'll do those things first, and then I'll divide my result. So within this parenthesis, I have multiplication and addition. So order of operation tells me that I have to do the multiplication first. So I'll do 3.2 times 30 in a calculator, and I get 96. 2.5 times 16 on a calculator is 40. 30 plus 16 is 46. I still need to simplify this top. 96 plus 40 is 136. And then I can use a calculator to divide. Top divided by bottom. 136 divided by 46. So combining her freshman GPA with what she thinks she might get this semester will give her a 2.96 GPA. Not enough to keep her scholarship. She's going to have to do a little bit better than 2.5.